Look up at the night sky tonight. Every star you see is doing the same thing. Burning, steady, predictable. That's what a star is supposed to do. But 400 light-years from here, there's one star that refused to follow the rules. Astronomers gave it a number. KIC 8462852. The internet gave it a name, Tabby's star. And for almost a decade, nobody could fully explain what it was doing. Here's the strange part. In 2009, NASA launched a space telescope called Kepler. Its job was simple. Stare at one patch of sky, watch for stars that dim. Because when a planet passes in front of a star, the star's light drops, just a tiny bit, like a fly walking across a light bulb. Kepler found thousands of these dips. That's how most exoplanets get discovered. But then it found KIC 8462852, and the dip wasn't tiny. A normal planet blocks maybe 1% of a star's light. This star dropped by 22%. Imagine turning down a light bulb by almost a quarter in seconds, then bringing it back, then doing it again at a different time by a different amount. No pattern, no rhythm, no planet does that. A planet is round. A planet blocks the same amount of light every single orbit, like clockwork. This wasn't clockwork. This was chaos. In 2015, a team of astronomers published the data, and they were careful. They didn't say, "We found something impossible." They said, "We found something we can't explain yet." That's the moment the story went global. Because when scientists ruled out the obvious answers one by one, they were left with a short list, and one candidate on that list wasn't natural at all. Here's how the reasoning worked. A dying star, coughing off dust, could dim unevenly. But this star wasn't old. It wasn't the right type to be dying. A cloud of comets, shattered and trailing debris, could pass in uneven clumps. That fit better. But even that didn't explain everything, especially something the astronomers noticed when they dug through old photographic plates. The star wasn't just flickering, it was fading, slowly, over more than a century. Comets don't usually do that, decade after decade. So in 2015, a Penn State astronomer named Jason Wright did something rare in serious science. He suggested that one honest possibility on a long list of possibilities was an artificial structure, something built, something orbiting the star, harvesting its energy on a scale humans can't even build a fraction of today. Scientists call this idea a Dyson swarm. Panels or platforms circling a star, catching its light for power. Wright wasn't claiming aliens. He was doing something more interesting. He was saying, this is what the data would look like if that were true, and right now we can't rule it out. That's not a UFO video on the internet. That's a peer-reviewed scientist at a real university saying the impossible explanation technically still fit the numbers. And for a while, that idea took over the conversation. Telescopes turned toward the star, listening for radio signals, searching for any sign of engineered intelligence. They found nothing. No signal, no structure, no proof. But here's the twist most people miss. The alien hypothesis didn't collapse because someone disproved it directly. It collapsed because something quieter and more elegant came along. In 2018, another team pointed a different set of telescopes at the star and watched it dim in real time. And they noticed something. The star dimmed differently depending on the color of light. Certain wavelengths dropped more than others. A solid object, like a metal panel or a spacecraft, blocks all colors of light equally. It doesn't care what wavelength it is, it just blocks it. But dust does something different. Dust filters light unevenly, letting some colors through more than others. The data pointed to dust. Fine, uneven, oddly structured dust. possibly from a shattered moon or a disintegrating comet or something in the system nobody has fully mapped yet. Not a machine, not aliens, just an extraordinarily strange natural phenomenon, doing something no other known star does quite the same way. And that's the part of this story that doesn't get told enough. The mystery didn't end with a boring answer. It ended with an answer that's still remarkable. Astronomers still don't have a complete model that explains every single dip, every fade, every irregularity. Tabby's star is technically unsolved, constrained, narrowed down, but not closed. Here's why this matters beyond one star. The real story here isn't about aliens. It's about how good science actually works. Nobody panicked. Nobody claimed certainty they didn't have. A serious scientist looked at data that broke the models, and instead of forcing it into a familiar box, he said the honest thing. I don't know, but here's every possibility, including the strange one. That's rarer than it should be. Most people, when they hit something they can't explain, either dismiss it too fast or believe the wildest version too fast. Tabby's star sat in the uncomfortable middle, for years, in public, under scrutiny. And it turned out the universe didn't need aliens to be strange. It just needed a star that refused to behave. So the next time you look up and everything seems fixed, predictable, already figured out, remember there's a star out there, 400 light years away, still keeping part of its secret, still burning, still, somehow, behaving like nothing else,